This is the fifth and final video on parametric equations. In this video we're going to have a look at how we can find the gradient function, so dy by dx, when we have our curve expressed in terms of a parameter t. So, talking generally for a moment, just to introduce the idea, we have x as a function of t, y as a function of t, and I want to find dy by dx. Okay, so in terms of differentiation here, I could find dx by t. I could differentiate x with respect to t, and I could differentiate y with respect to t as well. And I want to try and link these two things together so I can get dy by dx. To do that, we're going to use the chain rule, because I know that the chain rule says that dy by dx is equal to dy by dt multiplied by dt by dx, and those two things cancel out, hence why they're the same thing. Okay, now I already have a dy by dt here, so that's fine. However, I don't have a dt by dx. I have the reciprocal of that. I have dx by dt. So rather than multiplying by this, I could divide by its reciprocal. Just to make it clear that works, remember when we're dividing, we could multiply by the reciprocal here, so I'd be multiplying by dt by dx, so it does work. So this is my rule for finding the gradient function, when I have my x and y both expressed in terms of the parameter t. Let's have a look at an example. So, I've got x is equal to 3 sine theta, I've got y is equal to 5 cos theta, and I want to find the equation of the normal where theta equals pi over 6. Okay, so we know how to find the equation of the normal. We need to find the gradient. We're then going to do the negative reciprocal of that. We're then going to do y equals mx plus c. So, first of all, I'm going to use the rule that dy by dx is going to be equal to dy by d theta, in this case, divided by dx by d theta. Okay, so dy by d theta, let's work that one out first. So I'm going to differentiate my y function with respect to theta. When I differentiate 5 cos theta, I'm going to get minus 5 sine theta. I'm now going to differentiate my x with respect to theta. So differentiating 3 sine theta, I would get 3 cos theta. I can now put these into my rule here to get dy by dx. So dy by dx is equal to dy by d theta, so minus 5 sine theta divided by dx by d theta, which is 3 cos theta. You can probably see now why I decided to write my divide like this, because I can see clearly now that this is tan theta, so I'll get minus 5 over 3 tan theta. So this is my gradient function in terms of theta. I wanted to know the normal at that point. So theta is pi over 6. So if I work that out now, so dy by dx is going to be minus 5 over 3 multiplied by tan pi over 6. So that's minus 5 over 3 multiplied by, that's going to be root 3 over 3. So I would get minus 5 root 3 over 9. So that's the gradient of the tangent to my curve at the point where theta equals pi over 6. I now need to find the gradient of the normal. Which is going to be the negative reciprocal of this. So that's going to be equal to, so make it positive, and I'll have 9 over 5 root 3. Let's just rationalise that as well, so let's times that by root 3 over root 3. We will get 9 root 3 over 15, which simplifies a little bit more, and I will get 3 root 3 over 5. Okay, so here's my gradient. Right, I can now work out the equation of my straight line. So I'm going to do y equals mx plus c. I've got my gradient here, but I need to know my x and y coordinates in order for me to work out my intercept. So to get my x and y coordinates, I need to substitute pi over 6 into here and into here, so I can get my x and y coordinates. So substituting pi over 6 into here, so sine pi over 6. Sine pi over 6 is a half, multiplied by 3, so I get 3 over 2. Now substituting pi over 6 into cos, I'm going to get 5 lots. Cos pi over 6 is root 3 over 2. So there we go. I've got my x coordinate, I've got my y coordinate. I can substitute those into my straight line now. So y is 5 root 3 over 2. So y, 5 root 3 over 2 is going to be equal to m times x, which was 3 over 2, I think, plus c. And let's just tidy that up now and work out what c would be. So 5 root 3 over 2 is going to be equal to 9 root 3 over 10. Take these away. Going to need a common denominator. So times this by 5, so I get 25 root 3 over 10 minus 9 root 3 over 10. So c is going to have to be 16 root 3 over 10, which simplifies a little bit to give me 8 root 3 over 5. So, the equation of the normal, y equals m, which was 3 root 3 over 5, x plus c, which is my 8 root 3 over 5, and let's finally tidy this up a little bit by multiplying by 5. That is the equation of the normal to the curve where theta is pi over 6.